This is the short notes from section 3.6, solving three variable systems by substitution. We're only going to do substitution today here. We're given 4x minus 3y plus 2z equals negative 39. Negative x plus 2y minus 6z is 22, and x is equal to y minus 26z. So what we're going to do is we're going to take what x is equal to and substitute it in for x into one of the equations. I'm going to start with the top equation. So we've got 4 times x, and I'm plugging y minus 26z in for x, minus 3y plus 2z equals negative 39. So I'm substituting this into the first equation for x. Distribute. And combine like terms. So we get 1y minus 102z is equal to negative 39. The problem is I have two variables here. I have both y and z. So I need a second equation that has both y and z in order to solve. And we get that by, again, substituting. I'm going to take what x is equal to, and I'm going to plug it in for x into the middle equation. So we have negative x, which is y minus 26z, plus 2y minus 6z equals 22. Distribute. And combine like terms. And we get y plus 20z equals 22. So again, those two equations came from taking what x is equal to, substitute it into one equation, take what x is equal to, substitute it into the other equation, and simplify it. And then what we're going to do is we're going to take these two equations. We have two equations with two variables, y and z. So we're going to put those together in a system. So we've got that one, and I'm going to bring this one over. And then we can solve this with either substitution or elimination. Even though we use substitution here to get down to this, we can use elimination from here, which is what I'm going to do. So I want to eliminate the y's. I'm going to multiply the top equation by negative 1. Bottom equation stays the same. Add the equations together. These cancel. I get 122z equals 61, divide by 122, and we get z equals 1/2. Once you have one variable, you don't want to go back to one of the original equations, because if I plug in 1/2 right here, I can't solve it because I still have x and y. Instead, you want to plug 1/2 into one of these equations. Probably the easier one might be this one here. So I'm plugging 1/2 in for my z. 1/2 of 20 is 10. And that's easy to solve for y. And now, once I have two of the variables, now you can go back to any of the original equations and plug those values in. And I think pretty clearly, here's the easiest place to plug it in. X equals y, 12, minus 26 times 1/2. X is negative 1. You can write your answer like this and just circle them as you find them, or you can write it as an ordered triple, x, and then y, and then z. Either way of writing your answer is fine. Let's do one that's a little different here. This one here. Students sometimes struggle with this one because some of the variables are missing. Like this one doesn't have a b, and this one doesn't have an a, and this one doesn't have a c. But our overall strategy is going to be the same. So we know what b is equal to, c plus 7. And I'm going to take that and substitute it into one of the equations. I'm plugging it into the bottom equation. 2a plus 3b equals 25. And we put c plus 7 in for the b. Distribute. And I'm going to move that 21 over. So all my A's and C's are on the same side, and everything else is on the other side. So there's one equation. It has A's and C's in it. I need a second equation that has A's and C's in it. Remember, our strategy is to take what B is, substitute it into one equation, take what B is equal to, substitute it into the other equation. Problem is I don't have anywhere to put B, which is okay. If I put C plus 7 in for B, I just get this equation again. I get A plus 2C equals 0. That is the second equation. That's the second one we're going to put together with this. Now I can solve this system by substitution. I'm going to multiply by -2. Add my equations together. And I get C equals -4. Once we have C, I can put it in right here. I've got A is 8. And remember, C is -4. I'm going to put it in right there. All right, so talking through one more time what our strategy on these is to take what one of the equations, whichever one's solved, substitute it into each equation, and then set up a system that has 2 variables and 2 unknowns.